Hello everyone, welcome back to my channel, Physics with Chaos. In this lesson, we are going to consider voltage in series and parallel circuits. Welcome back. Voltage in series and parallel circuits. Starter. Which one is a killer? Voltage or current? Guys, pause the video and leave a comment in the comment section to answer this question. At the end of the video, compare the comment that you made with the answer that I'm going to provide. Voltage or potential difference, otherwise known as the PD. Voltage is the energy supplied per unit charge in a circuit. It is the energy supplied by one charge to a component in a circuit. It is given as V equals to E over Q. Potential difference V or voltage is the work done in moving a unit charge from one point to another. In this case, it can be expressed as V equals to W over Q. This implies that the energy supplied or energy transferred is the same thing as the work done. Potential difference is a type of force between 2 points which causes current to flow in the circuit. The PD of a cell that is given here on the left hand side, this, which is 1.5 volts, implies that 1.5 volts is the electromotive force or the amount of force that is required to move a certain amount of energy from one point to another. Okay, so voltage and potential difference are basically the same thing. Batteries. Batteries are the source of voltage or potential difference in the circuit. They store chemical energy which is transformed to electrical energy. Different types of batteries have different voltages, like what we have here. Okay, some are rated 1.5, some are rated 9 volts, and so on. Batteries are a source of the EMF or electromotive force. EMF actually is the potential difference in a battery when current is not supplied. We can also say that EMF is the amount of charge produced for one amount of energy produced for one charge to carry, okay, to circuit component when it's not connected. Other sources of EMF include the generator, the dynamo, solar cell, thermocouple, and so on. These are other sources that can actually create an electromotive force for charge to flow. Okay, now the idea of potential difference is explained by a water tank model. The water tank here showed water in the same level. Okay, tank A and tank B are in the same level. This implies that nothing will happen. Water will neither flow to tank B nor flow to tank A because they are in the same level. However, if one is at a higher level than the other, like what we have here. Tank A is at a higher level than tank B, then water will tend to flow from A to B until both get to the same level. A difference in the potential energy is what makes the charge to flow. This is how charge PD behaves. Once there is a difference in energy level, a difference in potential level, then charge will flow from the high energy region to the low energy region until it is being neutralized. If there is no PD, then there is no flow of charge at all. What's the meaning of the size of voltage written on cells? The size of the voltage here has two meanings. One of the meaning is the amount of energy that is supplied by one charge to a component. That implies that 1.5 volts means that 1.5 joule of electrical energy is transferred by one coulomb of charge to a component in a circuit. At the same time, 1.5 volts here tell us about the level or how much push or force the charge gets from the cell, okay, to move in a circuit. A cell of 3 volts gets more push than a cell of 1.5 volt, of course. This push is sometimes referred to as EMF or electromotive force. Why batteries need replacement after working for some time, or why batteries need to be recharged for those that are rechargeable. Okay, they simply need replacement because charges flow from the high potential region to the low potential region until it balances up or neutralizes. Okay, so for that reason we need to reverse the charge back to the high potential region, or we need to replace the battery itself. Okay, how is voltage or PD measured? A voltage is measured in volts using a voltmeter. This instrument here is called a voltmeter, symbol V. For you to measure a volt between 2 points, say a voltage in this component here, we need to connect the voltmeter in parallel to the points. Okay, it's connected in parallel to be able to find the difference in potential, the difference in the energy coming in to the circuit component and the energy leaving. Okay, like what we have here. In this case, we wanted to find the potential difference in across this lamp here. So what we do is we connect the negative terminal to the negative side of the connection of the lamp, the positive terminal to the positive connection of the lamp. Okay, in this way we'll be able to find the amount of voltage supplied to the lamp. Okay, if we needed to get the voltage in the cell, we'll do the same thing. We connect the negative terminal of the voltmeter to the negative side of the battery, the positive terminal to the positive side of the battery to find the voltage across the battery. Voltage in series circuit. In a series circuit, voltage supplied by the battery is shared by the components. So the sum of the potential difference across the components equals the battery's voltage. Okay, so as more bulbs are added, for instance, each of them gets a less potential difference. For instance, in this case, I have 6 volts that is shared by these two components as 3 volts and 3 volts. If I have an additional one more lamp, similar lamp, then each of the lamp shares will have 2 volts supplied to them. Okay, this implies that voltage accounts for the brightness of the lamp and not current. So if I have like 4 volts, then there are four lamps, then they are going to share the 6 volts, and it will make the lamp to become dimmer. Okay, so voltage is shared in series circuit. Take note of this fact. If you have 2 different components that consumes energy at different rates, for instance, you have a buzzer and a lamp, then the buzzer gets more of the voltage compared to the lamp. Okay, so if a buzzer is replaced here, it may take 4 volts, while the lamp will take 2 volts. Okay, but the summary of the fact here is that voltage is shared in series circuit. Parallel circuits. In parallel circuits, the potential difference across each bulb is the same as the potential difference across the battery. Okay, this means that all the bulbs have the same brightness. Like I said earlier, voltage accounts for the brightness of the lamp and not current. If I have 6 volts here of the battery, then each of the components in a parallel circuit will have the same amount of voltage. Okay, so voltage is the same in parallel circuit. Okay, if I have 2 components in a single loop, it means the amount of voltage, which is 6 volts, will be shared by the 2 components in the same loop. Take note of this fact. Summary for series circuit. In a series circuit, all the components can be controlled using one switch, like what we have here. Each component shares the voltage of the power supply, and so adding more bulbs in series will cause each bulb to become dimmer. Take note of this fact. If one bulb dies, the other bulb will not light up. Okay? And if you add more bulbs to the same loop, then the brightness will reduce. Okay? Total brightness of the bulbs will reduce. Good? Summary for parallel circuits. In parallel circuits, all the components can be individually controlled using a separate switch or using separate switches. Each component has the same voltage as the cell. So each of these components has an equal voltage as that of the cell. Here, brightness is not affected because they have the same voltage. And if one bulb blows or dies, the other will continue to work. Energy equation. Recall that V is equal to E over Q. Okay, that implies that E will be Q times V, where V is the voltage, E is the energy, and Q is the charge. Okay, in this case, our energy equation is going to be electric energy equals to charge times volt. This can be placed in the triangle formula. Okay, so that implies that Q, which is the charge, is giving us E over V. Okay, we can apply this in calculation. Our question here says calculate the voltage of a battery if it supplies 3000 joules of energy to 50 coulomb of charge. So in this case, I use my V equals to E over Q, which is the voltage, energy over charge, and that gives me 6 volts. Guys, at the beginning of the video, you answer the question in the comment section. voltage or current, which one kills? Now guys, neither voltage nor current kills on their own. It is a combination of both that kills, which is expressed as electric power. Now you should note that very high voltage and very low current may not necessarily kill. The same goes with high current and very low voltage. For an electric shock to kill, the current should be up to 10 milliamps and the voltage should be up to 50 volts, and this also varies with individuals. Okay guys, I believe you liked the video. You can leave a thumb up if you do, and you can also subscribe to this channel for more videos like this. Have a nice day.